We will start with today's topic. We will start with time and space complexity. Okay.
Okay.
So, like, have you heard it before? Like, if you like, what is time, space, something like that?
No, I have not.
Okay, that's fine. So, like, I will brief you why we need it. Like, whatever, whenever we start a new topic, right? We will ask us three questions. Like,
Okay.
what is that topic? Why that topic? And how that topic, like how that topic will help us. Any topic, and whenever I will start and teach in this way. So you had a good grudge over it. So basically, we will understand what is time and space complexity. So like whenever you run a code right in your computer or your computer or my computer, you can't judge the time taken by it depends on the computer it takes, right? Suppose my
Yeah.
computer is like 8 GB RAM. I have in my it is 8 GB, and suppose you have 16 GB or whatever, maybe higher or lower. So
Okay.
okay, now it will be faster, right? It will execute
Yes.
faster in your computer, but it may be slower. But you can't compare my I have proposed the algorithm and it takes, let's suppose in my computer 20 milliseconds and your it takes 15 milliseconds only, but it
No.
does not.
Okay.
And the same algorithm what I have made a run on my computer, so it does not mean that like you have made the that suppose you made the same algorithm and you it ran for 15 milliseconds in your computer and 20 milliseconds in in my computer. It does not mean that you are better or I am better. Both are same.
Okay. Okay.
You can't compare on the time taken by the computer itself. There should be a standardized method how you should analyze algorithms time and space complexity. Okay, both are same. Whenever you feel like you have any doubt, you can pause me in between and you can ask for
Sure.
question.
Sure.
No problem. So both are same timings. Okay, something like that. So how would it judge? Like the people have made a standardization how you can judge what time it takes an algorithms or takes, right? So they gave an
Mm-hmm.
idea of time complexity. We'll start with time complexity and we will jump on to the space complexity.
Okay.
So how it is been and how it is devaluate on different codes, like and it does not refer to actual time taken by a machine. I already told you. So what is the real purpose? How time changes with input size? Because whenever I propose an algorithm, what should it have? Like, what do you think an algorithm should have? Like, if you, I gave you an algorithm, and how did you judge algorithm? Like, what parameter do you think it's important
Mm, uh,
for like,
sorry. Can
yeah,
uh, sorry. Can you repeat your question again?
like I am asking, like I give you you understand what's the algorithm, right? Like
Yes.
noise
Yes.
is a problem, it's a solution to a problem. So I
Yeah.
gave you a solution. Now how will you judge a solution? Like is it better? How will you judge in terms of what you think, like whatever in comes to your mind?
So the way to judge the solution depend is it useful? So
Yeah,
does
is
it
it
get like the
useful?
job done? That's like the
Okay,
big.
makes sense. Means it's correctness, right? It should be correct.
Yeah. Yes.
It should be correct. And
And the
yeah,
second one is like how long it'll take in
yeah,
a sense, right?
exactly.
Because
Time
if it's
taken.
like a solution, I need it done quick. So yeah.
Yes, exactly. Right. What is the time taken by the solution? It should be fast.
Yeah.
And yeah,
And
like
then
and mainly we are concerned with these two parameter, and other thing is also a space also, like how much space it acquires. Suppose you propose a solution and it does not fit into my computer, so big
yeah.
space it required. So you have to care about the space as well, right? Space it requires. And there are other many factors, but we are concerned with mainly these factors, whatever we'll study, right?
Yes.
There are some other factors. Oh, sorry. Okay, yeah. Some other factors are also there, but we are not considering that. Yeah. So mainly we are concerned with what is the space it require, what's the time it require. Obviously, the correctness. We will focus on these three things, right? Okay. And like obviously it comes intuitively, right? Whenever your input size changes, like I give you a small input, it will take a smaller time and a smaller space. And if I give you a huge input, it ideally it takes more time and more space, right? Algorithm normal, right?
Yep.
Okay. So basically, how obviously versus the machine speed, the code execution time differs on low and high end machines. Conclusion time complexity is independent of machine speed, which I already told you. It does not depend how much slow or fast is your computer is. There is a standard method to compare standard method irrespective of machine. Standard method.
Okay.
My writing is actually not too good, so please bear with that. I will
Yeah,
try to
no worries.
improve it. So irrespective of. So what's the idea now? How we'll compare the time complexity of an algorithm? So basically, in coding terms, we represent with this big O type. This is called as big O, and whatever I feel is I will tell you later. This is known as big O, like big O. It's like it is literally it's big O. Whenever you
Okay.
listen, right? I think big O of n something like that.
Yeah.
So this is basically a big O. It says in time. There are many varieties also like omega and O and theta. They are not required. Mainly, big O is used whenever we are represent the time complexity in big O notation. O of n means, and if I give you an example, O of n, that does means that our algorithm linearly increases with the input size. And suppose I give you three elements, and it's supposed to take 3 milliseconds
Mm-hmm.
input size. And if I give you like 100, now the size of my array is 100. Now it takes 100 milliseconds. So this is a
Mm.
linear algorithm. So it's a linear algorithm,
Okay. Okay.
or also can be stated as linear time complexity. Linear time complexity. So basically, this is how there are many different types of time complexity. We can also say like O of big of n square means a squared time complexity squared, or you can say polynomial time complexity also square time complexity. Whenever a general polynomial is there, so we can say polynomial time complexity, cubic time complexity. So there are many example of. Okay,
Yeah.
so this is if I talk about this, so there's if it take 3 in 3 milliseconds, and then if I do 100, it will take 100 square. So it's just
No. Okay.
like that. So yeah,
Are
now
you
basic.
sharing your screen?
Oh, okay. So
Mhm.
you should told me, right? Okay, sorry, my
That's why I was like, I think you're typing, but I can't see it. That's what I was wondering.
sorry. Yeah, I
No worries.
completely forgot. I'm really sorry. Sorry.
Yeah, no worries.
Actually, I forgot.
Mhm.
Yeah. Okay. I
Okay,
will
now
show
I
you
can
from
see.
the beginning. Yeah. I wrote so many things. Okay. Okay, sorry,
Okay.
sir. Yeah. So basically, we started with the idea of time and space complexity.
Yes.
Like what is the time and space? So basically, yeah, I stated you whenever I start a topic, I will talk with three things like what is the topic, why we were studying that, and how we will study that. So basically, I give you an
Yep.
example of 8 GB RAM, 16 GB RAM. We can't judge on both these things on algorithm, right?
Yep.
Okay, and then basically I am defining what is actually time complexity means. Like time complexity helps evaluate on different code solution, because I will judge what according to what is the time complexity of that of your code. You obviously, it does not depend how you write it. Like maybe
Mm-hmm.
your it handwriting does not matter in that place. What matters, what is the time it takes. That's the most crucial point, right? And
Yeah.
in a different code solution, it does not refers to actual time taken by the machine. I clarify this fact only remember how time changes with inputs. So it's like how I change my input and how your algorithm changes according to that. So basically we talked about how which on what factors the algorithm depends. So basically how it should be useful, it should be correct, and what's the time it takes. It should be fast enough to give me quickly the solutions, and what it space it requires. So majorly we are concerned with these three things, and rest are other factors we are not concerned with yet. So yeah, and yeah, we already talk about like what is the time complexity within machine speed and standard method we will follow irrespective of the machine speed. Okay, so let's try now. Machine
Okay.
speed basically. This give you a good idea. Okay, what we are doing in time complexity. Okay, that's great. Now I told you like how we represent the time complexity. Like it's a theoretical time, right? I have to give a notation as well. So we express in terms of using of big O notation. This is known as a big O. It is not actually big, but okay, it's big O, and like in whatever you place inside, I will tell about later how to write it. But yeah, and what it defines, this defines what is our complexity. So suppose I give you an example of n, that it means that our time scale with linearly with input size. What is a
Okay.
it is a linear time complexity, and input size if 3, it gives 3 seconds. If it's 100, it takes 100 milliseconds. And if it is n
Okay.
square, and it's give a square time complexity. Whatever is the input, it gives the square of it, right? Okay, that's great. Now let us also examine how we can in actual code what it does it means. Suppose how we judge that. Suppose I give you a folder. Is red is better for you? Like I think maybe I'm not sure. Is it is
It doesn't
visible?
matter.
It's fine.
Yeah, I can see this. Yeah, I
Okay.
can see this.
Suppose I run a loop of suppose 15 size
Yep.
and I just print hello every time. Nothing else. Okay, sorry, my bad. Okay. I just printing hello. And if you find any like any problem in your basic concept as well, you feel free to tell me. I will just cover that topic as well. It's no
Yeah,
problem.
sure, sure.
Okay. So yeah, I just run this code, right? 15 times I run this code. And suppose I fit into in a function. I write a function for that. And
Mm-hmm.
I just fit this code. And whenever I call that function, let's say a print function, I call the name of the function as print. I just call it, right? Now it runs for 15 times. Now suppose I am not changing this 15, right? I am not changing, it is not n. Matlab, suppose I take an user input n and I am just doing other stuff with n, but this 15 is constant. Like I am not, it's not linearly changing. Whatever, whenever I call the function, and it will always print 15 times only, right? Irrespective of whatever I take the input, right? So
Yep.
this is known as a constant time complexity. It's a constant time complexity. It does not matter like how many times I call it, it always print 15 times. And it contrast to that, suppose if I, with example, I take user input as n, when I run a loop n times, less than n, 5 plus plus. And then whatever I job I do here, like here job, whatever I do, and I write in a function like n print, and I take a user input n from the user, and I just run this function. Let's make it void only. Now let's see. I call the print function, and it depends. Whatever is the input I give, this n could change. Suppose I put n equals to 1, so obviously it will run for one time. And if I put n is equals to 10 to power 5, so it will run for 10 to power 5 times, right? So
Yep.
this is changing linearly with time. This is a linear time algorithm or linearly with time. That's pretty much makes sense. Okay,
Okay. Okay.
right? So initializing, printing, and now we will analyze how much time every operation takes. So suppose I initialize a variable int I is equals to 0. It takes a linear time it's take a constant time complexity. It because we just initialize a constant time. Whatever
Okay.
variables we initialize, we write this if conditions, we increment it. they are all constant operations. Whenever we see a loop, we have to be very careful because it could be constant as well as it could be like I gave you a previous example, right? Here it was constant because I was running for 15 times every time. But here we are not running every time 15 times. We are running for n times. So here it is basically linear. So we should be very careful when we are analyzing the time complexity of a loop because it may change. Here it is n. It is not always n. I will show you an example. So you will hold a good see. So yeah. So this is like loops are very like mostly whenever you are given a question to reduce the time complexity, mostly it would be around loops only, right? So you should be very well versed with loops, right? Okay.
Yeah.
So this is done. Okay. Initialization, I already told you. Initialization, comparison, print, increment. Yeah, like if you just print also, out also, does not matter. They are all constant operation. Whatever you one line statements you write, right? Mostly are they are of basically constant time. Count, hello, all constant time. I'm not saying like it takes 1 milliseconds or something like that, but I'm just saying in terms of time complexity, like whatever course or structure we are designing, in terms of that, it is constant. Means it's not like the print operation and initialize operation takes similar time. It is not like that. I'm saying they are both equivalent to take constant time. Do you understand that? Like every
Yeah.
initialize operation take a similar time, right? It does not changes with
Yeah.
whatever we give. Yeah. So it is represented as big O of 1, whatever constant it is. Okay. This is also actually, if I write literally, this is O of 15 because it runs for 15 times, same operation. But we will study later, it will be reduced to big of 1 only. Like we will represent eventually to big of 1. But yeah, if you talk in literal term, it is O of 15 because it runs the same thing 15 times. So which is O of
No.
15.
Okay. Okay.
And we will actually care about this thing because we don't care about it is 2n or not. We don't care about this. We care about what is this. We care about this. Okay, what is the n? Because you right n square, and if you compare n, they are very much huge. Like suppose they how they changes 1, 2, 3 linearly it changes like that, right? But if you talk about squared, it changes like 1, 4, 9, 16, right? And if I just take 2n, the 2n does not changes very drastically also like 2, 4, 4, 6, 8. But if you go very long, right? The n square will be very huge than to n. So we don't care about the constants, whatever in that computations. We care about what is this vector. O of n it is there, of n square it's there. But
No. Okay.
okay,
Yeah.
so I think this is done from here. Okay. Before that, let's try to analyze more time complexities. So suppose I give you this thing. Do you know how to find a prime number? Through check a prime number whether a number is a prime or not, how to write a code for that.
Yes.
Okay, that's great. So basically we check, right? Int I is equals to like 2 we start because 1 obviously does not
Yeah.
matter. I less than that number. Suppose I for n I am checking and it's I plus plus. I'm writing a function for that. And suppose if n modulo I equals to 0, what should I return? Like whatever. If it is there, means it's not a prime, right? Because we find a factor for
Yes.
that. So basically, suppose we
Mm.
return 0, means 0
Yeah.
for it's not a prime, and return 1 if it is a prime.
For problem. Yeah.
1. So how this is how like whenever we are given a problem now I will ask you. So like I will ask you like to find prime. What is the time complexity? You can think of what is the prime for finding prime. What is the
Mhm.
time complexity? Because what with time what happens, the algorithm becomes more and more better. Now in old times we found a solution, but now can we optimize it? Can we think more, like, can we reduce it? Because now what's the time complexity according to you to find the prime? What we are using here?
Will it basically just be divided?
What like I'm asking the time complexity, like whatever you studied.
Like, yeah, yeah, isn't it divided by 8? Or sorry, by 2?
Uh, no. I'm just asking in terms of big O of, like, what is the time complexity we have studied, right? For this prime.
Oh, yeah. So in
So
that case,
big O of n, right? Like, because it's run, it does not. It depends on how big is the number is. We
yeah,
are running a loop for n times. Suppose the number comes out to be prime, so we will run for entire loop, right? We won't
yep,
return from here. We will return from here. So we, in the worst case, we will return from here. So it will run at something like n minus 2 times, right?
yeah.
So the time complexity will be exactly n minus 2, or which is roughly we can say, if we ignore the constants, we say if it is O of n.
Oh, okay. You mean like this?
Okay,
Okay,
and
okay,
now I will give you a good and better solution to find the
okay.
prime. This is the one method. This is method one. And now you can use many methods in the same algorithm. Suppose I will give you one more solution in the same complexity, because and that two solution won't differ. I will tell you why. Suppose I This is one way of implementing it, right? Suppose I
Yep,
implement it in method two. What I do, I just count how many factors it have. So I initialize a count variable, count equals to
mm-hmm.
0, and I just run a loop from 1 to n. Now this time,
Okay,
int I is equals to 1, I less than equals to n, and I plus plus. Okay. And what I do is, whenever I found a factor of it, I just count it. N modulo I equal to 0, I just do a count plus plus. And what I will check, if obviously my count is 2, means it's a prime number.
yep,
It is a two factors only. So we will return a 1, and if it is not, we will return a 0. Fair enough?
yep,
Okay. Now I will again judge its time complexity. What is its time complexity? I'm again checking. Now this times I'm exactly running n times, right? Because there's no return condition in between. So I'm running the loop for n times. So its time complexity is also O of n. Fine.
yep.
Now these two solutions are actually equivalent. This does not give me an edge, because suppose you wrote this solution, I wrote this solution. I can't compare both the solution because both are same actually. This is method one method, because the time we judge on the basis of time complexity. You wrote it differently. You use in
Mm,
extra variables, but I told you it is like constant time of one time, so it does not add to the count time complexity much. The main factor is
okay,
this
okay.
n. So actually these two solutions are same. So there's no difference in that. If I can reduce this time complexity, if I can do something of root n, then it would be better.
Okay, okay.
Okay,
Yep.
you're getting it, right? What I'm trying to emphasize here.
Yes.
Okay, let's try to write a O of root n solution. Do you know that there's a root n solution exist, or I should tell you?
I think. Can you tell me? Because I don't remember it.
Okay, that's fine. Okay, fine. So I will give you an idea how to find. This is a pretty cool stuff actually. How to find prime for in root n time. Suppose we take an example of 18. Okay,
Okay.
so I just write all the from, like, I will write a loop 1 to 18, something like that. 2 into 9. I'm writing the factors so it will be clear. 3 into 6. 4 it does not divide. 5 is also 6 into 3. uh, 9 into 2 and 18 into 1.
Yeah.
Can you see one thing? Can you observe? This is just a
Yep.
mirror image of this.
Yes.
6 into 3, 6 into 3, 9 into 2, 2 into 2, 8 into 8, 8 into 1, right? Now, what I'm claiming is whenever where I need to run this loop, do I really need to run from till n or I can do better? See,
Mm.
what I am claiming is I should run
Okay.
this loop int I is equals to 2, I square should be less than equals to n and I plus plus. Try to understand why I'm writing this and how it is helping me. See, suppose what's the square root of 18? Something around 4 point something. Let's say something 4.2 we are taking. Okay. What I'm saying is, suppose I is a factor of my number, is a divisor. Okay.
Okay.
Would n by I also a divisor?
Hmm.
Right? Suppose I take an
Yep.
example of 2. 18 by 2 is also a divisor, which is 9. Right? Suppose I take an
Yep.
example of 3. 18 by 3, 6 is also a divisor. So what we observe is I, if I is a divisor,
Okay.
n by I is also a divisor, is always a divisor actually. Because obviously, if I write I into n by I just split it into two factors, right? That n,
Yep.
it is n only. So n by I is always. You are able to see my face cap also or not? Only the screen is visible.
Yeah. No. No. I can see the face contour.
Okay, okay, that's right. So n by I is always a device. Pretty much fine. That makes sense. So this will help us. This I is okay. This we already know. This is a new thing. NY is also a divisor. Oh, nice observation. See, in coding, what happens is we make observations and then we use some maths, whatever you studied in your high school. We'll implement those stuff. Will make our life much simpler. Okay. So yeah, we observe this. Now, whenever I got n modulo I equal to 0, right? I will add, suppose I want to get all the factors of it. So I am making a vector.
Okay.
Divisors of factors, I'm saying factors. So what I will do is I will push back. I just remove this, push back. I will write in VS Code as well. Don't worry. I'm just giving an idea.
Yeah. Sure. Sure.
Don't push. I will push. This is already a factor. What I claimed was I will push as n by I as well. Push back n by whatever, yeah, like n divided by I actually back n by I. Now actually when it will redundantly calculate when our number is a perfect factor. Suppose it is a 36. So it has a divisor 6 as well. Now if I divide 36 by again, it will give again 6. So I don't want that, right? So
Yep.
I will put a if condition. I will put a if condition. If I into I is not equal to n, then only I will push n by I. Fact dot push back n by I. I will always push. I will always push. But n by I will then only push when I into I is not n, because n by I and I become same in that case, right? Push back I.
Yep.
Okay. So this is this. And what I figure out through this way, I just need to run the loop till square root of n, the I value. Because suppose I run to 1, I run to 2, I run to 3, 4 is not divisible. Just only tell that. Because I will get these things, this one, this one from n by I.
Okay.
Right? This is a
Yeah.
very cool idea. Now let's try to see what we are going to do. So I just formally write the code in the VS Code so it would be more clear.
Sure. Sure.
You have VS Code installed, right, in your computer?
Yes. Yes.
Okay. Okay. So, and this is already, I think you know this bits std C++. This is a complete library. What we, it's a boilerplate code we write here.
Yeah. Mhm.
Okay. So suppose I just want to, I just take n from the user, say n, and I just need to check whether it is a prime or not. So I will just give all the factors of it. So just I creating a variable and I just run whatever we discuss. We will run the loop from I equals to 2 to I into I less than equals to n. Because why I running through square root of n, I already explained it because n by I we will cover here. So suppose
Okay.
if n by n modulo I equal to 0, that means I is a factor. That means that also means I is also a factor. Just I need to check if firstly I will push back dot push back I. That is pretty much fine. And if I into I already told you if it is not a perfect square, if it not equal to n, I will push n by as well because it will not be written there. N by I. Let's see how it works. So yeah, just printed all the factors. I in this is also a pretty cool way to print all the elements if you want to do it. If first way is to run a loop like this to I less than fact dot size. This is a boring, like pretty boring thing. Like
Yeah.
that you can do. I think you know that, right? Fact of I.
Yes.
Let's try to do something else. We can shorten our code. So this is one way. What we can do directly in a vector, what we will do in I, instead of writing everything else, you can write just like this. It will also do the same thing. It will iterate in all the complete vector and it will do that. So yeah, it's like pretty shorthand for this thing.
Okay. Okay.
Okay. So yeah, I remove this. I will follow this practice because I also uh, tell you that this follow this one. This will be better, easier, and also cool. So yeah. So let's try to give an example. I guess. Let's say 18 only we give. Oh, wait just a second. I think this I made a mistake or what? I do I. Oh, okay. Just made a mistake or what? Just a second, please. I not equal to n. What happened? Should not do that. Fact of. Oh, okay, okay. Sorry, my bad, my bad. It should be I. My bad. I just printed something else. I should print it. Yeah, yeah. Sorry. Yeah. So
Mm.
basically 2, then 9, and then 3, and then 6. I'm not printing 1 and 18. Yeah, you can start with 1 to print 1 and 18 as well. Okay.
Okay.
Yeah. This is that, and yeah, the other way to print whatever I told you, like int I is equals to 0. That's why the habit of we have a habit of fac of I, right? Like factor of I to print everything. So yeah, you can do that as well. Just yeah, I plus plus, and just you have to be careful. Here you have to do fac of I. Here I just printed I means this means that we are iterating the list as a I, integer I, and we are printing that I only. And here
Yeah.
we are
Okay.
this is the index. So basically we are printing with the help of the index. Okay. So
Okay.
yeah. So this helps us to reduce our time complexity. This the solution I wrote here, I square n. This helps to reduce our time complexity to O of square root of n, which is a huge task. This is a very good one. We this is a better solution than there's both previous solutions because they are both of O of n, and now we create a good solution which is of square root of. There may be better version of that. If someone comes with more optimal, then that would be better than my solution as well. Okay. Till
Okay.
now,
Okay.
it is the best solution to find the prime. Okay. So
Yep.
yep. So this is yeah. Now I think in between I told something known as the worst case scenario. What does that mean? A worst case scenario. Okay. Yeah. So what is what whenever we are comparing or computing whenever we compute time complexity, we check the worst case of that algorithm. We check the worst case of that algorithm. Worst case of that algorithm. What does that mean? Means how bad and how not in terms of bad, how much iterations or how much computations it will take in the worst case. Suppose I will tell you in our previous example, this prime example, this one.
Mm-hmm.
Suppose what is the best case? There are three terms. One is best case, one is average case, and they are more intuitive. Whatever the name suggests, it means that only average case,
No. Okay.
and it is a worst case. We generally define time complexity with the help of worst case because it makes sense. Because best case and average case, maybe it's fine, but actual thing hits when it's worst. So we have to be careful what is the worst we can go whenever if you thinks of terms of taking risk as well, right? Whatever you take risk, what you analyze, what is the worst case scenario. you you can get bankrupt or what. So you have to think in that
Yeah.
terms, right? So you can take too much huge big risk. So yeah, so in the same in terms of coding as well. So yeah, what do you think? Like, what is the best case in this algorithm of checking the prime? How much
The best.
computation? Yeah.
The best case would be, tells us the prime.
What?
It tells us the prime number.
Yeah. Basically, if I give the input as suppose two only, not two. Actually, two is it's a prime actually. Okay, we should be careful enough. It should be started with two, but okay. Yeah, two is not a prime. We will start. Suppose I give you four,
Mm-hmm.
and in the first go itself, it gives
Yeah.
n modulo I equals 0 and it returns. So how many computation you do? Only one.
Yes.
So this is the best case we can get.
Oh, okay. Best case, it will be like the least. Okay. The
Yeah,
least.
least number. That's the best case, right? Average case we will
Okay.
talk it later. Worst case we will analyze. Suppose the number comes out to be prime. We have
Okay.
to iterate in the complete because this condition never becomes true because there won't be any factor, right? Suppose I take an example of 17. So we will go to completely. We won't encounter this if condition. We will return from here. So what's the worst case? It's O of n minus 2 or O of n, whatever. Something like that, right? So
Yep.
that's why I wrote the time complexity is O of n. I could write O of 1
Mm,
as well because in best case it is giving O of 1 time because only one iteration. But in the worst case, this is hit. It's O of n. So that is important. See, so yeah, and the average case here itself is also of n. Average case is that thing. Actually, you can't compute it directly. Average case, it's like maybe how much time it takes averagely. Like suppose it's take one value, it's take two value, take a average, whatever. Whenever how you take averages, right? So yeah, in actual
yeah.
time, it's almost similar to worst case only. You can think like that. Suppose okay.
Okay. Okay.
So yeah, best case I already do. So you don't judge on the basis of best case. You judge on the basis of worst case. Okay.
Oh, judge on the
Now
worst.
we
Okay.
will analyze this one. What's the best case, average case, and best and worst case according to you? This algorithm.
Sorry, your voice cut off. What did you say?
I'm asking like, can you describe me like what is the best case and worst case of this algorithm?
So the best case, you would only take one. So just go through the if loop and that's it. The worst
Yeah,
case is.
but we are not returning here. Try to understand. We are not
Oh yeah.
returning
Yeah.
here. This loop, this code is running every time n times.
Okay. Okay.
Okay, because here at the after the loop we are returning because we are counting, because yeah, so you can say in terms of like that, in terms of best case this algorithm is better, because in every case, like in best case or worst, in both cases we are running often.
Okay, sorry. Then the best case
Not
it will be three, right? Yeah, one, two, and three. The worst case it'll be five because it'll go through the for loop, if loop, plus plus, and then it'll go through the if loop. But if that doesn't work, then it will return.
yeah, like but we will count eventually every factor in that, so
Yes.
it does not matter. It is a best case or worst case, because suppose I take an example of 17. For 17 also it will count the factor, and it comes out to be 2, but it will run from 1 to n, 1 to 17. And suppose I take 16, it does not matter, in between it got more factors than 2, but we are not returning at that moment. We are still checking and it's
Mm,
all factors, and suppose whatever the factor 2, 4,
okay.
8, and like 4 it have, right? In
Yeah.
both the cases we are running the loop for n times. Whether it is a prime or not, it does not matter to me. This is how we implemented it, right? So in
Yeah.
best or worst case, both cases it is overfed. Do you understand that?
Yes.
Okay, okay, that's great. So we talked about what's the best case, what's average case, how we judge whether a solution is good or not on the basis of worst case. We don't judge on the best case. Best case is a good handy thing, but worst case we analyze. Okay, we talked about this. Worst case I already told you. Always calculate the worst case for that. Ignore constants. I already in between told you. You can ignore, avoid constant terms in terms of complexity analysis. Ignore lower values. What does that mean? I will tell you. Focus on higher order terms for larger inputs. Suppose. Firstly, I will tell you the in terms of constants. Suppose I give you an algorithm of O of A10. It is similar as O of n. It does not matter. This constant does not matter. Suppose I give you an algorithm O of uh, n plus 1, n plus 25. It is also similar to O of n.
Okay.
Now, now same goes as well as the higher order term. Now try to understand. This is very important. Suppose I write an algorithm where I am running a nested for loop and also a single for loop. So the time complexity of the both of them added. Suppose I write a for loop here, I less than ni plus plus, and I wrote another for loop for int j is equals to 0, j less than n, and j plus plus. What do you think? What's the time complexity of this algorithm? Yeah, like what do you think? What is a worst case time complexity?
Worst case would be one, two. They'll they'll just keep going.
You keep going, right? So like how many
Yes.
iterations it will do in terms of that? Like in terms of you go of something, can you tell me?
He'll basically go until I is, I guess, not being able to be greater than n.
Yeah, this is going to n and this is also going to n. So how many times it will run at max?
Max will run.
This will loop will run n times, right? And this loop
Yeah,
also
this will
run n
just
times.
loop until n. Both of them would, I guess, in a sense, loop
And
until
and
n.
and total, how you write it? Do you add it or do you multiply it?
In that case, you would.
Because these are nested for loop, right? They are not two separate
Yes.
for loops. They are nested for loops.
You would. It'll be
Okay, try to
it'll be
guess. No
for
problem with that.
it'll just be forever now.
What
Because
what?
well, it'll just keep going because in a sense it's not nested, right? It's not
No,
grounded.
no.
It'll keep
This is
going.
nested. This is nested, right? This is
Sorry, that
nested.
one's nested, but yeah.
So basically, like in terms of big of something, can you tell me like what is the exact time complexity? Do you think?
Okay. So, mm,
Because see, I told you what the time complexity of a single for loop. We already discussed this is O of n, right? Now
yeah.
this is another for loop inside that. Now how I decided the time complexity, how many iterations it will perform. So in total, this will perform n into n iterations, right?
Yes.
And this that means it has a O of n square complexity. In terms of that, I must say.
Okay.
Suppose,
I see.
do you know that this is n square? It runs n square. Like, I will show you. Like if you don't know that, right?
Yeah.
Suppose I write a nested for loop. You know the difference between a nested for loop and two different for loops, right?
Yes, yes. I know that.
Okay. I less than n I plus plus, and for int j is equals to 0, j less than n, and j plus plus. Suppose I need to count how many times it will run, right? So I just make a counter
Okay.
and just I will just increment every time whenever I go through it. I just do a count. Let's try to check how many times it runs to count end of L. Okay, I'm just removing this thing. It's not required now. Yeah. So let's suppose I give you 3. How many times let's see it will run. So let's suppose I give n the value of 3. So it will run 9 times. Right? Because
Yeah.
for every I, this for loop will run. And for suppose I equals to 0, this for loop will run for 3 times. Then for I equals to 1, this for loop will run 3 times. And for again I equals to 2, this for loop will run 3 times. So in total, the complete it turns out to be it turns 9 times it will run, right? So n into
Yep.
n. So that's how you compute the time complexity of a nested loop. Whenever you see a nested loop, you just multiply the time complexities. But suppose now instead of a nested loop, I will give you just a second, two different for loops.
Okay.
I less than n1, I plus plus. And suppose I just give you print hello. Sorry, print not count. Count hello. And just I just copy paste the same thing. Now, what do you think? What is the time complexity of this entire code? Yeah,
Mhm.
I try to think.
The time complexity for this
Hmm.
would be one, two, three, four.
What's the time complexity for this one?
That'll just go till n.
O of n1, right? I wrote
Yeah.
n1. Okay, okay. For this
That'll
one,
be it'll be the same.
it would be same, right? It is O of n. And for
Yes.
the entire one,
It'll just be n squared.
no, no, no. Try to understand. Last time I wrote in nested things. This was nested,
Oh,
and this
okay.
time I wrote it separately. That's the difference,
So,
right? Now they will be
oh,
added.
no, okay.
Right?
Okay.
Because
Yeah.
this will be separately run n times. This will separately run n times. They're independent. And
Yes,
if
yes. Okay.
they are like for each I, this loop will run. Right? So this is n square
Yeah.
and this is O of 2 n1 you can say.
No, okay, okay.
Which reduces to O of n. Got it?
Yes.
So yeah, this is the thing. Okay. So yeah, I think pretty much from this side today for me. Yeah, like do you have any doubts? Whatever I taught today,
No.
like I will quickly
Right
revise.
now. Right now it's good. Like I understood it.
You understood everything, right?
Yes,
So
today it was good.
I just quickly revise what we have covered today. That today we understood the notion of what's the time and space complexity, how we judge it, what's the definition, big of and notation, and algorithm, how we judge it, and now instead of irrespective of machine we judge, and yeah, n square, and we gave some example, constant time of one, big of notation, and then we just simple loop. We just analyze, okay, how many time it runs. If it is constant, it does not matter it is 15 times or it is 100 times. If it is constant, it is constant. We ignore the constants, and I just gave you an example, and we just see an example of prime,
Yep.
how to judge the time complexities. We gave two solutions of O of n, and then we just optimize this further, and we have a good idea. Using math, we analyze a O square root of n solution, and we just updated that. And then basically I explain your nested for loop time complexities of n square. Suppose if it is nested one more time. Suppose for loop inside a for loop inside a for loop. It runs
Yep.
n1 times, it runs n2 times, it runs n3 times. Suppose what is the time complexity then?
Okay.
It
So
is,
for this,
yeah, it is nested three times inside them.
yeah. So if it's nested three times, it would just be plus. Sorry, not plus. It would
Yeah,
be
yeah,
cubed.
yeah. Like it should be n1, n2, n3, right?
Yes.
Yeah, that's how it works. In nested, we whenever you go down, it would be multiplied, and if it is basically different, like it will be addition. Like it's not nested; they are independently written for loops. There are three for loop written. You sum them all. If they're nested, you product them all. And we
Yeah.
just analyze how we judge it. Don't judge on the basis of best case. We judge on the basis of worst case scenario. Just ignore the constants, and yeah, ignore the lower values. I just talked about this O of n square plus O of n, because see, O of n square will be greater than n, right? Always.
Yep.
So we just ignore that aspect to make our life simpler. You can write this thing also. This is also not wrong. But if someone, if in options, like suppose if you have an objective exam, you will be getting this. You not will not be getting this. So yeah, you have to understand. Okay, this and this are same.
No.
This
Okay.
O of
Okay.
n square, and I just told you, you ignore the constants, ignore the coefficients, you just ignore them all, and just reduces to simple terms of n square, of square root of n. So yeah, so yeah, so pretty much from today, like we taught. If any doubt, feel free to